Hello everybody and welcome back to another visual pattern challenge. Wow, this is a big one. Here's figure 1 of our pattern. Here's figure 2. Here's figure 3. Your job, your challenge is to find out how many of these little circles are going to be in figure 4. If you think you can do that, can you try to figure out how many in step 40 in figure 43? And could you write an equation to predict the number of circles in any figure at all? So that's the challenge. This is a toughie. If you'd like to take it on, pause the video and give it a shot. All right. The first thing I notice about this is that it's getting big really, really fast. We've got 6 little circles here, and then let's see. Oh, there's 6 of the 6 circles. There's a circle. Oh, okay. So we started with 6, and now we have 6 times 6. So that's 36. I think I'm going to actually make a chart right now with the figure number and the number of circles. So figure 1 has 6, figure 2 has 36, and then in figure 3, yeah, we've got 6 circles of the circles of 6, so it'd be 36 times 6, which is 216. So I'm guessing for figure 4, we would have 6 of these big circles with the more circles and the little circles inside them. So it would be 6 times the previous step, so 6 times 216. Let's see, that is 1,296. Glad we're not drawing that out. That'd take a long time to draw 1,296 little circles. So maybe you can see already what's happening here. We've had a couple of functions, a couple of patterns like this before, where they're doubling or tripling or quadrupling. In this case, it's sextupling every step. And in this type of pattern, if you try to take the differences, that's 30. And then let's see, what is 216 minus 36? I'm just going to do this on my calculator so I don't make silly errors. So 216 minus 36, that's 180. And then 1296 minus 216 is 1080. So that's not a constant, although they all are multiples of 6. And then if we take the differences again, this is 150, and 1080 minus 180 is going to be 900. And you could go on forever like this. Every time you'd get a multiple of 6 as you kept taking a difference after difference, and it would never resolve to a constant, which is what we try to do to determine if a pattern is linear or quadratic or cubic or something like that. So this is what happens when you have an exponential pattern. And an exponential pattern is some number raised to a power. That number is the amount that it increases by, the amount so if it's doubling, then the number is 2. If it's tripling, the number is 3. So in this case, it's 6 times every step. So we're multiplying each step by 6. That means this is 6 to some power. And you can start with just x and see if it works. In figure 1, we'd put in 1 for the x. 6 to the first power is 6. That is how many little circles there are. How about in figure 2? 6 squared is 36. That's exactly how many little circles there are. 6 times 6 is 36, and so on up. So this pattern can be described just by the equation 6 to the x. So how do you figure out how many in the next step? Well, you take 6 to the 4th power, and that is 1296. How do you figure out how many in step 43? Well, you take 6 to the 43rd power, and you're definitely going to want a calculator for that. I'm getting 2.28 or 228, something like that, times 10 to the 33rd power. So a 2 and some decimals, and then times 10 with 33 zeros. That is a huge number. I don't even know what to call that. I don't know the name for 10 to the 33rd power. Something, I bet there's something out there. You could look it up and let me know. Well, that was definitely the most humongous pattern we've ever seen. How did that go? Did you recognize that this was exponential? Did you get 6 to the x? Let me know. Thanks, everybody.